The unique elements of successive rows of combinations of elements, such as indicated here, are revealed by k equal 2 combinations of the elements. The unique k equal to k greater than 2 groups of a set are produced by partitioning into subsets the set of elements combining into k equal 2 groups. For example, this set of elements is partitioned into the subsets 1 here, 2 groups in this subset, 3 groups in this subset, and 4 groups in this subset. This mechanism produces what I term a system. Now, if we let S equal the number of order k equal 2 combinations exhibited for t elements of a set, for example, we can say that here are t elements and here are the k equal 2 order combinations. And this set of combinations then can be looked at as a set of elements that produces this successive row of combinations and so on. Then the combinatorial value of such a system will equal the square root of 2s plus 1. Here I give the formula, factorial formula, for the number of t elements and s elements. So, if we look at the count of k equal 2 possible groups of the second row, here, the row of single letters, it will exactly equal the count of k equal 2 unique groups. That is, these 5 unique elements in combinations of 2 produce exactly 10 unique elements in this next row. So this indicates that its ordered pair S and T equal 10, 5 is not a resultant of vector addition. One might say that its space is flat in that case. Now, the count of k equal 2 possible groups of the third row of double letters, this third row, doesn't equal the count of k equal 3 unique groups. There's actually 45 possible k equal 2 groups, but there are only 10 unique order 3 elements. And so therefore, we will have to partition this group. And it's partitioned into a group of 1, 2, 3, and 4. And then if we look at the unique combinations that can arise, order 2 combinations from each of those partitions, we will see that for the 2, there will be 1 unique combination. For the 3, there will be 3 unique order 2 combinations. And for the 4, there will be 6, given the exact number, 10, unique order 3 combinations from this set of elements. And therefore, this indicates that its ordered pairs, ST, equal 10 for S and 10 for T, results from the vector addition of these ordered pairs. 0, 1, 1 for the 2 elements, 3, 3, and 6, unique order 3 for the 4. And if we continue, we will see that the count of k equal 2 possible groups of the 4th row of triple letters, this 4th row that we just created by combining the row of double letters, it also doesn't equal the count of k equal 4 unique groups. This k equal 4 unique groups. And so must be partitioned. And we see it's partitioned into a group with 1 element, a group with 3 elements, and a group with 6 elements, equaling 10. And then these groups are farther divided, as we can see here. We have 1, and then in this 3 we have 1 and 2 subgroups, and then in this 6 we have 1, 2, and 3 subgroups. Those subgroups then produce 3 ordered pairs, having the values 0 for S and 1 for T, 1 for S and 3 for T, 4 for S and 6 for T, which when the S values are added up, we'll see we have 0 plus 1 plus 4, which equals this 1 plus 4 for 5 of the next order of k equal 4 groups. And so we see that this is partitioned into a group of 1 and a group of 4. And if we investigate the remaining group, we will see that for it, as there are the number of partitions, there are 2 order pairs and 2 vectors adding to generate its combinatorial value. And in this case, we have the 1, which will give us 0 for S and 1 for T. And then we have the 4, which is divided into a group of 1, plus a group of 3, which is divided into a group of 1 and 2. Therefore, the only new unique combination that is given is the order 2 combination of 1. And so, therefore, these 2 vectors, when added, will produce only the single k equal 5 group of elements. Now, this partitioning of these sets of elements, I have come to speculate is related to the curvature of space. Whenever you have this partitioning, then you have what is equivalent to space-time curvature, which we will explore in other places with more detail.